Okay, hello everyone. So this is Justice, and I have on my screen a past question. This is question number 6, and I think it's from AS Probability and Statistics 1. That is May-June 2025, paper 52, if I'm not mistaken. So if you're watching, you can check if it's the right paper, but it's a past question, right? And this is the A part of it. Now I will do my best to solve the remaining questions. Now this question actually caught my interest. That's why I decided to share a video on how you can go about this. Okay, so we have the word. Now let's read the question. Find the number of different ways in which the 10 letters in the word amalgamate can be arranged so that there is an M at the beginning, an M at the end, and no A's are together. So we have 3 conditions that we're supposed to satisfy so we can come up with the final answer, right? Now the first condition is when we have an M at the beginning. So let's rewrite this word again. Now we have the first condition stating that we should have an M at the beginning, right? So we have M at the beginning. Then we should have an M at the end. So looking at the fact that we have 10 letters, if we have an M at the beginning and an M at the end, we are going to have 8 positions left in between them, right? So let's do that right here. 1, 2, 3, 4, 5, 6, 7, 8, then our M, right? So we have this right here. We have M at the beginning and M at the end. That is for the first 2 conditions. Now, the final condition is that no A's are together. Sorry. There are 2 ways in which we can go about this. Now, to solve this question, we can either look at finding the number of ways we can arrange the remaining 8 letters in this scenario. Then we subtract the number of ways we can arrange this word with the A's together and subtract it from what we talked about initially. That is the number of ways we can arrange the 8 letters, right? And that will give us the number of ways we can arrange this word or the letters in this word with the A's not sitting together. That is one way of doing it. Then the other way is we can just go straight ahead with what the question is asking for. That is, we just go straight forward and look at the scenarios where the A's are not together, right? So with this one, we are not going to do any form of subtraction from any particular huge value or any particular arrangement, you understand? So these are the 2 ways you can go about it. The first one is you find the number of ways you can arrange the 8 remaining letters, then you subtract the number of ways you can arrange them with the A's together, and you subtract, right? So after the subtraction, you would get the number of ways you can arrange them with the A's not being together. Okay, so now let's look at the first method, and I would like my first method to be we looking at the number of ways we can arrange the 8 remaining letters, then we subtract the number of ways we can arrange them with the A's together. Then that will give us the number of ways we can arrange them with the A's not being together. That will be my first method. Then in my subsequent video, I'll talk about the second approach, that is going straight ahead, looking at the number of ways to arrange them without the A's being together. You understand? Okay, so let's start. Method 1. Okay, so the first thing we look at for this method 1 is the number of ways we are going to arrange the 8 remaining letters, right? So let's call it the number of ways for arranging this as T. So we have our t is equal to, now we have 8 positions here for 8 letters. So we talk about 8 factorial, right? The number of ways we can arrange these 8 letters in these 8 positions. We talk about 8 factorial, right? But one thing that we shouldn't forget is that we have A's repeating themselves in here. So we have the A appearing 4 times, right? Now, when that happens, it means we have to divide by the factorial of the number of times the A is repeating itself. So that is 4. So we divide by 4 factorial. Now one will ask why. The reason is, as you can see, we have 4 A's. We cannot differentiate which A is different from the other. You understand? They are basically the same. So if I switch the A in front with the A in the middle, or any of the A's, I will not be able to identify which A has been in which particular position before and which A has not been in that another position before. You understand? So it's kind of a bit messed up position. So what we do is that, since the number of ways we can arrange 8 distinct letters is 8 factorial, then we have to divide by the number of ways, the 4 A's are kind of the number of ways some letters are repeating themselves, so that the A's are no longer treated as distinct values or distinct letters because they are the same. You understand? So the A's will be treated like a block in this particular scenario. So that is the main reason why we divide by 4 factorial. That is because the A's are 4. Now, if the A's were to be 3, then we would divide by 3 factorial. If they were 2, 2 factorial. You understand? Okay. So let's move ahead. Now, with this, you can use your calculator, and I'm not going to show the calculator on my screen, so I'll just use my calculator off screen and tell you the final answer. You can follow by also using your calculator to check whether the value I'll put as the final answer for this equation is valid or it's wrong. So we have 8 factorial divided by 4 factorial, and that gives me 1680. That is 1680. Right, this is what I get for this. That is the number of ways we can arrange the 8 remaining letters in the 8 positions that we have. Okay, now we are going to talk about the number of scenarios, or the number of cases where the A's are together, right? The number of cases where the A's are together. So let's talk about case 1. For our case 1, we start with the 4 A's sitting together. So we treat them as a block, right? So imagine we have A in this position, A in that, A in that, and A in that. Then we treat them as a block. So treating them as a block, it means we kind of treat them as if they're one, like one letter. You understand? So if we have this as a block, then how many ways can we arrange them? You understand? So if we decide to move them, what will happen is, first of all, the position they would require, or their initial position right now, is one way of putting them, right? So we have 1. Then we can move them 1 step ahead. So that will be this one. And that will end here. Right. So we have this position as 1. We have this position as 2. Okay. Then we can move them again. We have this 3. Then we can have this 4. Then we can have that 5. Right. So we have 2, 3, 4, and 5. So we have 5. Right. Now, if we have 5, then basically we're talking about 5 factorial. So let's call this particular case T1, right? So T1 is equal to 5 factorial. Okay, so that is for the first case. That is if we sit the 4 A's together. Now let's talk about the second case where we can have the A's together. Okay, now with this case we're going to talk about if we have 3 of the A's together. Right, 3 of the A's together. Now mind you, when we have 3 A's together, right, we cannot join the 4th A to them, because once we do that, then we will come back to what? 4 A's sitting together. So it's going to be 3 A's, then a space. Then we can talk about putting the single A in different positions. You understand? So if we're looking at the 3 A's together, let's demonstrate that as well on our screen. So we look at this. Let's erase this one. Okay, so let's demonstrate with this one. We kind of have to do this. So this is our method 1. Okay, so we're going to try and demonstrate. Right, so with this we have this particular scenario where we have 3 A's and a space. Right, then we can have the single A. Let's put it right here. Okay, so we can treat these 3 A's as a block, right? So the first position they find themselves is what? One way of putting them. Then we can, but mind you, the space is also important. So the space has to be added to the block so that the single A can know where it's supposed to be without causing any mayhem or reverting the whole thing back to case 1. Right, so let's, okay, so we treat this up to the single, the empty space as one way of putting this. Then we can also talk about moving them from that position to this one as 2, then from this position to this as 3, this to that as 4, then this to that as 5. So you see that we have 1, 2, 3, 4, and 5, right? So we have 5, and in this case that also gives us 5 factorial, right? 2, then we have 5 factorial. Now that is for the 3 A's. Now let's talk about the single A. The single A has 4 positions where it can fit itself, right? So at the moment it's filling 1 out of 4 positions, right? It's 1 and it has 4 positions it can fit itself in. So basically it can fit in this one, that is where it finds itself at the moment, 1, or this one, or that, or that one. Okay, so that gives us 4. So 4 ways we can put this A. So we multiply the 5 factorial by 4. Okay, now that is the end of the second case. Let's talk about the third case, case 3. We can have 2 A's, right, sitting together, but because we don't want the 2 A's, that is the 2 set of 2 A's coming together to revert the whole thing back to case 1 where 4 A's sit together, and it means we have to add a space there before we can talk about the second block, which is also 2 A's, right? So we can treat two A's plus an empty space as one block, and two A's without any empty space as also another block, right? And let's demonstrate that one right here on this screen. So let's erase this. Okay, so we have two A's and an empty space, right? And we can treat that as one block. One block, then we can talk of the two remaining A's. And we will treat that one too as another block. Right, so for the first block, its current position is what? Is 1. And then we can talk of fitting them in this position where the second block is, right? So this one is 1, then when we move them from here to where this one can be fitted, then we can call it 2. Okay. Okay. So we can call it, we can move it from here 1 to this part 2. Right. Or fit it in here, call it 3, 4, or 5. Right. So we move it from this part to this place. That is where the two A's are fitted because they are treated as a block. So it's 1, right? So we put them in there and that gives us 1. Right. Then we can fit it in this position 3, 4, and 5. So we get 5 factorial for that. Let's call it C3. So we get 5 factorial for it. Then what do we multiply it by? Now when we look at the second block, right, that is the one with the yellow mark. Its current position is 1. We can fit it in here 2, in here 3, and 4. Right, so that is what we have here. But one thing that is vital to mention here is that the A's, okay, there are two sets of A's, right, basically are repeating themselves. So we have two A's and two A's in here. So it means the set of two A's are what? Are repeating themselves. So it means we have to divide, just like we did for this particular part. We have to divide this one by 2 factorial. Don't forget I mentioned that if the letters are repeating themselves 3 times, we divide by 3 factorial. If they are repeating themselves 4 times, 4 factorial. If it's 5, 5 factorial, 6, 6 factorial, and what have you. Right. So in this particular scenario, there are two sets of A. Basically, the set of A, right, that is a set of two A's, are repeating themselves twice. So we divide by 2 factorial. Then we can now move to the final case, which is case 4. Okay, case 4. Now for the case 4, we're going to talk about treating the single A's, right? We're going to treat the single A's and also a set of two A's, right? So we're going to have one A with a space in front of it and another A with another space in front of it. Then we can have two A's sitting together, right? So we have single A, and two A's sitting together. That's what we're supposed to do for our final case. So we can demonstrate that on this. So let's see how we go about that one as well. Okay, so let's clean everything then. Okay, so we have A with a space, and then another A with a space. Then we can have our A and A. Okay, so we can treat them as blocks. Let's treat this one. This one is one block. This one is another block, and this one another block, right? So we have this, that, and that. So let's talk about the number of ways we can fit this one. So we have, for the first single A, we have how many ways of fitting it? We have let's see, we have its current position as 1, we have this position as 2, right? Then this position as 3, that as 4, and this as 5. Okay, so that gives us 5 factorial in this case. So that gives us T4, another 5 factorial, like we've had in. Okay, 5 factorial multiplied by, then let's talk about the next block, that is the one with the red line on top of it. We can talk of its current position as 1. Then we can talk of moving it to this particular part, so let's call this one 1, 2, 3, and 4. So we have that in here, 4. Then let's talk about the one with the yellow mark on top. So its current position is 1, that is the 2 A's, right? So 1, 2, and 3. So that is that one. Then mind you, the single A's are kind of repeating themselves, right? We have single A and single A. So the single A with a space, single A with a space are kind of repeating themselves. So we have 2 of that. So we divide by 2. Okay. So 2 factorial, not 21. Sorry about that. 2 factorial. Okay. So that is what we have at the moment. Okay. Now that we have all these cases, what we're going to do is we're going to add the 4 cases and subtract from the T, and that will give us the number of ways we can arrange this word with the A's not sitting together, right? We have the 4 cases which demonstrate or which indicate the A's sitting together. So we're going to subtract from the number of ways we can arrange 8 distinct letters in this manner. Then that will give us the number of ways where we can do the same arrangement but with the A's not sitting together. So let's see. Let's call let's say the variable for that, of what the question is asking for, as nt, right? So nt, the number of ways, let's say number of ways, total number of ways. So that will give us capital T minus, then we add the t's for the various cases. So we have T1 plus T2 plus T3 plus T4. Okay, so once we do that, now we can put in the values, right? So we have 1680 minus, now we have T1, T2, T3, and T4. Now when you check the T1, T2, T3, sorry, and T4, one thing that is vital to note here is that we have 5 factorial repeating itself across, right? So we can factorize the 5 factorial out. Right, then we can put the remaining in the square bracket. So for the first case, when we factorize 5 factorial out, we'll be left with 1. Plus the second case, we'll be left with 4. The third case, we'll be left with 4 divided by 2 factorial, that will give us 2. Then the last case, we have 4 multiplied by 3, that will give us 12 divided by 2, and that will be 6. So that is our square bracket. Then we kind of move to the next step. So we have 1680 minus 5 factorial right. Now when we add what is in the square bracket, we get 13, so we multiply by 13. Now you can use your calculator and check 5 factorial multiplied by the number 13, and that gives you 1560. So you have 1680 minus 1560, and when you do that, you end up with 120. So this is the number of ways we can arrange the 10-letter word with M at the front, M at the end, and none of the A's seated together, right? So that is the final answer. Now in my next video, I would show you the second method, that is the approach where we go straight ahead looking at the A's not seated together, instead of having to find a number of ways to arrange the 8 distinct letters, then finding the number of ways the A's are together, and you subtract that from the number of ways of arranging the 8, then you get the number of ways the A's are not together. The other way is a bit shorter compared to this one, but yeah, I'll show it in the next video so that you can decide which of the two methods you prefer. And I think preference will be based on which one you understand the most, you understand, or which one you're very comfortable with. So that is the end of this video, and if you have any question, you can put it in the comment section. Now till we meet again, Dozabachenya, adios, and bye for now.